Low pre-calc, we're looking at a review exercise, kind of pulling all this together about our sinusoids, where we're moving up, down, right, and left, changing their amplitude, and so on. So this is going to be viewed on Thursday evening on the 6th after class sometime. So what I would like you to do, we'll play a game. I'll do one, you do one. So what I'm going to do is the odd ones, and that will bring back to mind how these work, and then you will do the even ones and bring them in tomorrow and we'll grade them. So let's see, number 1, y equals 3 cosine x. Notice that's the first kind that we learned, and it's when we change the amplitude. So I'm going to draw a cosine curve, even though if I'm pretty sure what this is going to look like, and always put in the tick marks. And name at least half of them. At least name pi and 2 pi. And all of them wouldn't hurt. So I'm going to pencil in cosine, or tap in, dot in the cosine curve. So now I can go off of that. This is the parent function, the basic function that is in this expression. So I'm going to go up to 3. And down to -3 with my amplitude. So the highest point it's going to start at, comes back down, goes back up. Alright, so that is an amplitude change of a +3 for the cosine curve. So I want you to take the second one and do that one. Y equals -1/2 sine x. So when you do that, notice the negative in front of this, in the amplitude position, that negative sign will flip the sine curve. And the 1/2 will take the amplitude up and down 1/2. So sketch that for me and number it number 2, and we will check it tomorrow. Alright, now I'm going to do number 3. You can pause to do number 2 or come back to it. Alright, number 3. Y equals cosine theta plus 2. When the expression has a plus or minus at the beginning or end, not inside of the argument, then it will move it up or down. So this is a cosine curve again. I'm going to dot in the regular cosine. And I'm going to move it up 2. I like to do the 5 points. I take the 5 most prominent points. I took the lowest point, the highest point, and the points where it crosses the x-axis, and I'm just going to move them all up 2. So this will go up 2, this will go up 2, up 2, up 2, up 2, and then I connect the dots. And you can see that that blue looks like the whole graph was raised up 2, which it was. Alright, see if you can do 1 minus the sine of theta. This time we're going to start with a flipped sine curve, a negative sine curve, and we're going to move it up 1. So go ahead and practice that one. You may pause or come back to it. The next one, number 5. This is where we exercise a right and left motion. And that theta has the actual negative or positive value is hugging the theta. It's inside the argument. It is right next to the variable. The sign is applied to the whole value. So you'll see it inside parentheses, unlike the number 3 example. Alright, so with this one, we learned that this will be the opposite. It will be a right. We're going to go right pi over 2 with the sine curve. So here's the sine curve. Here's pi. Here's 2 pi. And I'm going to move it to the right pi over 2. So that's this much. So this, I'm going to put in my 5 points and move them all to the right pi over 2. So this one, this one, this one, this one, and this one. Then I connect the x's. You see the blue looks like the yellow, except moved over, in this case pi over 2. If you would take a negative cosine curve, so start just drawing a regular cosine curve that's been flipped by the negative sign, and do what this expression asks of you. Alright, so that's number 6 is on you. I'm going to come back on number 7. And when we have an expression here next to the variable, it's sort of tucked in between the name of the function and the variable, we have a position k change. And that deals with the period, whether we're going to squish it up for a smaller period or stretch it out for a longer period. So let's see how far we have to go to put in one cycle of the sine. We're going to come over and use our secret formula for k. K is always the period, the normal period divided by the new period. So this k change will affect the new period. So we have k is in the 1/3 is in the k spot, 2 pi divided by the period. We're wondering what that new period is, so we can sketch it. So we will get pi equals, p, the period equals 6 pi. So it's easier to sketch that if you put in tick marks that are more appropriate. So here's 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, and 6 pi. So I'm going to do one whole cycle within 6 pi units, and I'm going to flip it. So the regular sine curve starts here and goes up. This sine curve will go down. Alright, so I did one mountain and one valley in 6 pi radians. This one went a little high. I'm trying to aim it at 1. Alright, so for your exercise, you are going to do number 8. Does that show up? Y equals cosine of 4th eta, I believe it did. Alright, I gotta go teach another class, so I'll come back with part 2 with a little more review for tonight. Till then, over and out.